Okay, so, yep, Sat 3, this is the test we give right at the start of Term 2. It's a short unit, it's just on Chapter 7. So we'll review the content here. We've got a summary of all of the skills involved. So I'll leave that to you to have a scroll through in your own time, but maybe let's flick over the page and get straight into the questions. So we got 6 questions to get through here. I reckon we will breeze through them. Okay, we've got policemen inspected the safety of tyres on cars passing through a checkpoint. The number of tyres, X, which need replacing on each car follows the distribution below. So you either have 0 tyres that need to be replaced, which has a probability of 0.68, 1 tyre that needs to be replaced, 0.2, etc. Part A says find the value of K. So we know for a valid probability distributions, all of the probabilities add up to 1. This is a 1-mark question. It's just a statement. You don't need to show any working out. All just to show you, all of these probabilities, 0.06 plus K plus 0.02, are going to add up to 1, so we can determine the value of K. So here we'll have 0.88, here we have 0.94, 0.96, so K has to be 0.04. Okay, find the mode of the distribution. So this is a discrete probability distribution, right? And so it's different from normal distribution because it has whole integer values. So you either need 0 tyres replaced or 1 tyre replaced. You don't need half a tyre replaced. Okay, they're discrete values. And the mode is the event that has the highest probability. Okay, so the highest probability is 0.68, and the event that corresponds with that is 0. The mode is 0. The mode of X is 0. That's part B. Part C, find the probability of X being larger than 1. Okay? And interpret this value. X being larger than 1. So because it's larger than 1, probability of X being larger than 1, it means it has to be 2 or more. So this is the probability of being 2 tyres replaced, plus 3 tyres replaced, plus 4 tyres replaced. It's going to be the sum of all of these, which will be 0.12. Interpret this value. This is the probability of needing 2 or more tyres changed. Okay, then we have another probability distribution. This one is Ernie's going fishing. He's either going to catch 0, 1, 2 or 3 fish, and the probabilities of each event is shown alongside. On average, how many fish would you expect Ernie to catch for the fishing trip? So here we're asked to calculate the expected value, the mean of the distribution. So we've got what we call E of X, or the mean of this distribution, and it's equal to each event multiplied by its probability, all added together. So that's going to be 0 times 0.17, plus 1 times 0.28, plus 2 times 0.36, and then plus 3 times 0.19. Okay, so we can type that into the run map part of our calculator, or in statistics, we can have list 1, list 2, and get the calculator to do it for you. They're probably both going to take about the same amount of time at the moment just for this question. So I'll just do it in the run map. So what have we got? 0.28 plus 0.72 plus 3 times 0.19. 1.57. So what that means, on average, Erin catches 1.57 fish per trip. Okay. And 0.3. Okay, another distribution, we're asked to calculate the mean, median, mode, and standard deviation. So, the mean is E of x, 1 times 0.3, plus 2 times 0.4, plus 3 times 0.3. So what have we got? 0.3 plus 0.8, that's 1.1, plus 0.9, the mean is 2. The mode is the event with the highest probability, 2. Now just on this notation, right, we use lowercase x for the possible events that a discrete variable can take. Okay, the variable could be number 1, number 2, or number 3. And then we have the probability that the random variable corresponds with this event. Okay, so we've got the mode, and then the median. The median is the event such that the cumulative probability reaches / exceeds 0.5. So we can see at this event the probability is 0.3, and when we add the probability of the next event, we're going to get 0.7. So over the course of this event, the probability exceeds 0.5. This is the event that corresponds with that. So the median is also 2. And then for standard deviation, we'll use one of the formulas for calculating the standard deviation. So I've just turned the page backwards, 7D at the top there. Calculating the standard deviation, we've got this formula. And this one's probably listed as well on your formula sheet that SACE provided for you. Yes. Although they've listed an alternative formula, there's 2 formulas. They've listed one that's a little bit different from the one I've shown you. X squared. Yeah. So you can use either of those. There's 2 ways of doing it. Anyway, I'll go with the one I've got on the previous page. The sum of each event squared multiplied by its probability, and then we have take away the mean squared. Okay. All right, so that's going to be the sum of each event squared. So the first event, 1 squared multiplied by its probability is 0.4, plus the second event squared is 2 squared multiplied by its probability, 0.4, plus the third event squared multiplied by its probability. So we have the sum of each event squared multiplied by its probability, and then we have take away the mean. So the mean we saw was 2. So all of that added together, take away 2, and then square root it.
0.3 with the 1.
So
0.3.
Oh, thank you, 0.3.
No, I mean as in it's 0.3 times
For the
1 squared.
probability of no, the first one.
The first.
Yeah.
Oh, that's 0.3.
Yeah.
Ah, very good. Very good. Good pick up. Yeah, 0.3 is the first probability. So you haven't evaluated it fully. So we got 0.3 plus 1.6 plus 9 times 2.7. That's 1.6. 4.6, take away 2, and then the square root of 2.6. Yep.
Is it the mean squared? I mean, yeah.
Yeah, good pickup. That's squared as well. Yeah, so you've got to be careful with these, make sure you follow the formula properly. Right, so, and then I've got square root of 0.6, root 15 on 5. 4 to 3 sig figs, 0.7745. 0.775. Alright, we got there. Now, the other thing you can do is you can check these kind of calculations manually, right? I've said if you type that information into the stat mode, list 1 and list 2, and you have your settings correct, it's going to generate all of this information for you. So that's going to be a way to affirm that you've got the correct standard deviation. Often with standard deviation, when I've seen it pop up in the exam in the past, they've said stuff like, write an expression that could be used to calculate the standard deviation. So all they want to see is that you can write this statement here, okay, correctly. All right, let's move on to the next one. We've got Dominic is a door-to-door salesman. Each day he earns $100 plus 25 for each sale made. From previous experience, he knows the numbers of sales will be distributed according to the distribution below. So we've got 0 sales, probability 0.17, 1.25, 2.3, 3.15, 4.1, and 5.03. Okay, find E of X. Let's use our calculator to find the E of X, the variance and the standard deviation. So in your calculator, in list 1, you've got the events, and in list 2, you've got the respective probabilities. So events 0, 1, 2, 3, 4, 5. Probabilities 0.17, 0.25, 3.15. 1.03. Very good. So then what we're doing, just check your settings. So you go press calc and press calc settings, and we want list 1, list 2. Okay, that's what we want the first 2 things to say. The 1 var X list, list 1. The 1 var frequency, list 2. And then we're just calculating the 1 var. So it's going to bring up the mean. Now what are we after? It wants E of X. Yep. The mean 1.85. It wants the standard deviation of X, which is 1.314. And it wants the variance, and the variance is the standard deviation squared. So that one we'll have to calculate ourselves, unless it lists it here for us. So 1.31 squared, almost 2. 1.716. 1.72. Okay, so we put this distribution into our calculator, extracted the information it's asked for part A, onto part B. Suppose Y is the amount of money Dominic earns in dollars per day. Write Y in terms of X. So it says Dominic earns $100 per day plus 25 for each sale made, where each sale is the variable X. Okay, hence find the expected value of Y, the variance of Y, and the standard deviation of Y. So flick back the page, we're looking at 7E, properties of AX plus B. So if we want to find E of Y, the expected value of Y, that's the expected value of this one here, isn't it? 100 plus 25x. And hopefully you can see the relationship between the first dot point and what it flows on to be. It becomes 25 times the expected value of x plus 100. Alright, so it's the coefficient of the variable multiplied by the expected value of the variable, and then that constant just hangs out. So in our circumstance, 25 times 1.85 plus 100. So 46.25 146.25. Okay, and we can follow suit for the variance and the standard deviation. So I'll just clear this off. Variance of y is a squared times the variance of x. So 25 squared times 1.72. Okay, and then once you've got the variance of y, you can just square root it to get the standard deviation, or you can use the formula that they've given you there as well. That's 5 root 43. Yeah, the modulus of a times 2, 32.8. Getting there. Alright, so there, just some number crunching, follow the formulas, get the answers. Any questions about that one? Or any of the prior ones? Let's move on to the next one then. So we're on to now some Bernoulli distributions. So we have, consider the spinner alongside, let x equals 1 be the outcome if it's red, so that's the shaded area, and x equals 0 if the outcome is white. Explain why x is a Bernoulli random variable. So, two properties for a Bernoulli random variable. One, trial. Okay, you're repeating the experiment once. And there are two outcomes which are declared as success or failure. Okay, so we have two clear outcomes, or we've got one, we've got 0. Okay, so let's draw the distribution for it. So we've got the events, you get 0 or 1, the probability of getting white, and the probability of getting red. Now, for a Bernoulli distribution, it just flows straight on from a normal distribution, okay? What you'll see is if we were to calculate the expected value, we're going to have 0 times that plus 1 times this. All right, it's 1 times 3 and 4. So the mean of this distribution is 3 and 4. And that's also what we call the value of P. It's the probability of a success. Remember how that flows into the binomial? So for a Bernoulli distribution, the mean is P, and P is the probability of success, and a success is 3/4. And the standard deviation is a little bit more involved. Square root of P cubed. Alright, so that's going to be the square root of 3 on 4 times 1 on 4, square root of 3 on 16, root 3 on 4. Alright, so that's 5, and then on to number 6, beautiful. Okay, number 6, we're talking about the binomial distribution. So we've got BPD and BCD calculations, and we'll point out a number of ways that this can be performed. Records show that 6% of items on a production line are faulty. A random sample of 12 items is selected with replacement. Find the probability that none will be faulty. Okay, the replacement's important because it's saying the probability remains the same. Okay, the probability is not changing. Find the probability that part A, none will be faulty. So let's do this in two ways. The first way, I think the most intuitive way, is to say it's the probability of having zero items fail. All right? And for a BPD calculation, that's 0 successes, if we define a success as when the item is dodgy. 0 out of 12. So remember, we go X and P. That's how we type it into our calculator. There were 0 events, 0 needing replacement out of 12, and the probability that it needs replacement is 6%. So we can type that into our calculator. That's going to generate the answer. So that's the first way, using the BPD mode of the calculator. The second way is to think about the BPD formula, which is this one. The probability of the binomial variable being a particular event is equal to this formula here. Okay? The number of ways we can have k successes from n trials, the probability of a success to the number of successes, the probability of failure to the number of failures. So in this circumstance, all right, we've got 12 successes. We're talking about 0 replacement. The probability of it needing replacement is 0.06 to the number of replacements. And then multiplied by the probability of not needing replacement to the number of not needing replacement. Now, something interesting happens here as well, further, okay, is that if you process this a bit, or if we understand a little bit about what these go to, this becomes the number 1. 0.06 to the power of 0 is also the number 1, and so we have 0.94 to the power of 12. Okay, that's what we're left with. And of course this is the case because it's a conditional probability event. Okay? You've got the probability of the first one not needing to be replaced is 0.94. Okay? Then you're pulling another one out. What's the probability of the next one we pull out not needing to be replaced? 0.94, so we have to multiply those together. Then multiplied by the third one, by the fourth one, by the fifth one. We have 0.94 to the power of 12. So what we expect. Okay, so that's a long drawn out way of saying this is probably the best way to do it. Has anyone evaluated it?
0.476.
Thank you. 476, very good. Okay, let's move on to the next colour. So we got B, at most 1 will be faulty. So careful with the language. At most 1 is faulty. So that means the most that could be faulty is 1, and from there downwards. So it's this, it's the probability of X being less than or equal to 1. So this is a BCD calculation, all right? The lower boundary is 0, that's the least amount that you can have faulty. The most you can have faulty is 1 out of 12 trials, and the probability of it being faulty, 0.06. Okay, so when we think about how many can be faulty, 0, 1, 2, 3, 4, okay? It's saying at most 1 is faulty. Now, we've already calculated this event. What the calculator is doing when we type in this syntax is it's going that event plus that event, okay? It's saying the probability of multiple events occurring. Anyone evaluated it? Please, yeah. Option stat distribution binomial BCD 0, 1, 12.06. 0 0.8404, 0.840. Okay, that's B. At most 1 will be faulty. Part C, at least 2. Okay, at least 2. This is the probability of it being 2 or more, right? That's the probability of this event. Now, 2 ways we can calculate it based on what we found already. We can go, yep, that's BCD from 2 to 12 out of 12, probability 0.06. Or, so you can type that in if you want, we know that all of these events add up to 1, and we know that this event is 0.84, so this event here has to be the remainder of the probability, which which is 0.16. Okay? 0.16 plus 0.84 will equal 1, all probable events. Alright, or you can type in your calculator, that's fine. And then we have less than 4 will be faulty. Now, if it says less than 4, this is what it means in terms of mathematical syntax, probability of x being less than 4, which is the same as x being less than or equal to 3. Because if it's less than 4, it means it has to be under 4. The next whole possible value that could occupy is 3. So this is a BCD from 0 to 3. Our upper boundary is 3. 12 trials, 0.06. Zero, 3, 12, 0.06, 0.9956. Very good. Okay, so from memory, like everyone did really well on this test. It's one of the easier units. So yeah, let's spend some time going over chapter 7. Up to you.